Hello everyone, this is Martha from the Academic Support Center at Raritan Valley Community College. This video is going to be about simplifying rational expressions. So we're going to work through 3 examples and I'll do my best to talk through each of the steps. So let's get going. Our first problem is x squared minus 1 over x squared plus 2x plus 1. Now, right away on the top, there's this great giveaway. It's factoring out a perfect square. Anytime where you've got something that's a perfect square in each of the terms right here, the first x squared, and then a subtraction minus, and then another perfect square, we write it out where we've got a squared minus b squared equals a plus b times a minus b. This is kind of the recipe that goes into making this. So luckily for us, this makes it pretty easy to factor the top. The top becomes x plus 1, because 1 times 1 is 1. That's that b squared term, times x minus 1. So thankfully that knowledge of factoring out perfect squares really can save us some time. So over here we've got x squared plus 2x plus 1. Let's see if that will factor down and how we can do it. So I take the way that I do it is I take my first coefficient, or the number that's attached to the variable, to the x squared, and times it by my constant, or the number at the end. So I say 1 times 1 is 1. Now, what factors of 1 add up to positive 2? And when writing this out, I often write it twice, and I'll show you why. So 1 times 1 is 1. And also negative 1 times negative 1 is also 1. So then I would add these two together. 1 plus 1 equals 2. Negative 1 minus 1 equals negative 2. So now I know what goes in my terms. Because 1 and 1 equal my middle term here, positive 2, I do x, positive 1, x, positive 1. And just a little explanation on that really quickly. Whatever these numbers are and the sign that goes with them, we can do x and then what goes here. So if my variables were negative 3 and 2, it would be x minus 3, x plus 2. Anyway, so that was a quick detraction. So let's go back up to our expression up here. Now let's see if there's anything where we have a 1 in disguise or we can cancel it out. X plus 1 times x minus 1 over x plus 1 times x minus 1. Hey, look, there we go. This just means 1. Or you can cancel it out, whichever way of thinking works for you. So this expression, x squared minus 1 over x squared plus 2x plus 1. We broke it down. That top was a perfect square. That bottom, we factored it all out. And our simplified expression is x minus 1 over x plus 1. Now, something important that we're going to be looking at a lot is when would this denominator equal 0? Whenever that is, we've got to remember that it's undefined. So here we know that x cannot equal negative 1 because negative 1 plus 1 equals 0. So it's undefined at negative 1. So let's erase this and we'll go on to our next problem. Maybe I'll just clear the board next time. That might take a little less time. All right, finally. So for our next problem, let's do 2x plus 6 over 3x plus 9. Now here in this example, we can't really factor it out like where we've got x in one parenthesis and x in another, but we can ask ourselves, what can we take from each term to factor out? So in this top term, we can factor out a 2 from each of these. So we're going to have 2 times, and what's left over, 2x divided by 2 is just x. 6 divided by 2 is 3. And again, that's because we could pull or divide out a 2 from each of those terms. So let's look down at the bottom. Let's see, there's a 3 multiplied in this term, and there's another 3 multiplied in the second term. So we can pull that out, a 3 from each of those. And then that becomes 3x divided by 3 is x, plus 9 divided by 3 plus 3. Hey, look, this is another place where we can find the hidden one or cancel things out. So our simplified version is just 2 over 3. So 2x plus 6, we can factor out a 2 from each of those terms. And then over 3x plus 9, again, we can factor a 3 out of each of those terms. We're left with something in common. That means it equals 1. And so our answer for this is 2 over 3. Now our next one, the bottom term or the denominator, is a little bit trickier to factor. And so I'm going to write using what I call the AC method. Your professor might call it something different. There's a lot of ways to do it, and it's just fine. So we have x squared minus 9 over 2x squared plus 7x plus 3, Now the top is pretty easy to factor. We have x squared, and then 9 is a perfect square. So if we use this formula up here, a squared minus b squared equals a plus b times a minus b. This makes our life a little easier. We've got x plus 3 times 3 is 9, so that's our b. X plus 3 times x minus 3. Whew, okay, the top is done. Now let's do the bottom. And I like to factor using something called the AC method, because this is ax squared plus bx plus c. So that's where the a and the c come from. The a is my coefficient attached to that x squared variable. My 3 is that constant at the end. I multiply those together. I say, okay, 2 times 3 is 6. And then I list out the factors of 6. And again, I write these twice. We've got 1 and 6, negative 1 and negative 6 equals positive 6. 2 times 3 equals 6, and also negative 2 times negative 3. That equals positive 6 as well. So I said, okay, I've multiplied a and c together to get 6. But now I need to know, when I add them up, what equals b? What equals that coefficient attached to the x variable? So 1 plus 6 is 7, which was nice to get that right away, but let's see what the others would have been. Negative 1 minus 6 equals negative 7. 2 plus 3 equals 5. And negative 2 minus 3 would be negative 5. So if my b term was negative 7, I would use negative 1, negative 6. If it were negative, this should be negative 5. If it were negative 5, I would use negative 2, negative 3. So let's move on to the next section. Now that we know this, we've got 2x squared plus 7x plus 3. So I'm going to write this 7x. 7x equals 6x plus 1x. So I'm just going to write it like that and space it out. So I've got my 2x squared plus 6x plus 1x plus 3. What I'm going to do now is factor by grouping. And so I look at each group and I say, okay, what do we have in common? Here, this 2x squared plus 6x, I can take a 2 and an x from each of these terms. So 2x, and then if I take 2x squared divided by 2x, I'm left with just x left over. And if I take 6x divided by 2x, I'm left with just 3. And so over here, I'm going to do something that might seem a little tricky. I'm going to factor out a 1 from each of these. So plus 1, I can 1x divided by 1 is 1, or is just 1x. And then 3 divided by 1 is 3, so it stays the same. So x plus 3. Now what I'm going to do is I can factor this x plus 3 from each thing. So I pull it out to the side. So I've got x plus 3. I've taken it from this first term because they're being multiplied together, and because they're being multiplied together, I can divide it out. So what I'm left with is 2x for my first term plus 1. So now through the AC method and finding what equals the middle term and then factoring by grouping, I've been able to factor this 2x squared plus 7x plus 3, which looked a little tricky. But now I can plug it in up here. And again, on top, it seems like it was a while ago, but we had that perfect squares. And so we've got x plus 3 times x minus 3. And on the bottom, our factors are x plus 3, 2x plus 3, or 2x plus 1. Ooh, let's get that right. And then this equals 1. And so my simplified version of this is x minus 3 over 2x plus 1. I hope this has helped, and have a great day.